This is lesson 2.1 on relations and functions. So we have a nice little 4-square organizer that's going to tell you the definition, characteristics, examples, and non-examples of functions. So the definition, a relation in which each, please write this in, each input has exactly one output. So each input has exactly one output. So each domain has exactly one range. Each x has one y. So we'll talk about that here in a second with the examples and non-examples. Some characteristics, a graph, the quick test for a graph is called the vertical line test. You might remember what that is, but we'll talk about that. It must pass this vertical line test. The x variable, the numbers for x or the domain values cannot repeat. And in a mapping, x cannot arrow to more than one y in a mapping. So here's some examples. So if I'm looking at a table, focus on the x column and double check that none of the x's repeat. So 11, 13, 15, 17, 19, those are all different. So this is a function. Similar with ordered pairs. Look at the x values or the first number in the ordered pair, 2, 4, 6, 8, those are all different. So that is a function. The graph in the center has to pass the vertical line test, meaning if you draw a vertical line anywhere on the graph, it only passes once there. You can draw another line somewhere else, but it only will pass through that once. And then your mapping, you can see that all the x's are different. There's not an arrow from the x side that's going to more than one y on the y side. So some non-examples. You can see this first graph here. If you draw a vertical line where these circles are, it passes through that point twice, so that fails the vertical line test. In the x column on the table, the 8 appeared twice, and it was going to 2 different y values, so that is not allowed. In your ordered pairs, you can see the 1 in the domain, the first set of numbers, the 1 went to a 0 and a 7, so the 1 in the x values repeated, so that's a no-no. And in your mapping over here, you'll see the 9 is going to a 2 and a 3 at the same time. So I think about this like your x is your person, the y is the place. So if 9 is trying to go to 2 different spots, think about me trying to go to science and math class at the same time. It's not really possible to do that. All right, so these 6 questions I want you to try on your own. I'm going to go through a few more examples with some detailed explanations, but you can come back to this page and just say whether it's a function or not, and we'll talk about that tomorrow in class. So relations can be represented in many ways: ordered pairs, tables, graphs, maps, or equations. So for these 4 examples that you're going to see, we're going to state the domain and the range, and then determine whether it's a function and explain. So for this first one, we have a set of ordered pairs. The domain is the set of x values, and the range is the set of y values. So we need to know that. So for domain, I'm going to underline in red all the domain values. So I'm going to write domain. It's going to start with a little curly brace, and we're going to list all these domain values. So -6, -5, -3, -1, and +6, and close it. The range is going to be the second number in the ordered pair, so I'll underline that in blue. So the range values, again, we're going to use little curly braces. This is a -1, -9, -7, +7, and as you can see, -9 appeared twice, but we're only going to list it once. So don't list any repeats. So you might want to make a side note here. Don't list repeated values in the domain and range. All right, so remember, if I'm trying to see if ordered pairs makes a function, it's all about those domain values. So I'm looking at these, seeing if any repeated, and they were all different, so this is a function. So I'll say yes, it's a function. all domain values are different. You could say this in multiple different ways. I'll try to rephrase it different each time so you can hear a couple different things. All right, the table. So we're going to start with domain. So that's all the x values. So a 2, a -1, a -2, and -1 and +2 are already in the list, so we can just write those 3. The range are the y values. So this is going to be -2, -1, 0, 1, and 2. So is this one a function? The answer should be, well, let's check out the top row. We got 2, -1, -2, -1, and +2. So you can see the 2's repeated, and so did the -1. So it has repeating domain values. So this is not a function. You could say domain values of 2 and -1 repeat. Or you could say they go to more than one y value. Okay, then we have 2 more. First letter C is a graph. So for domain, we're going to think of all the ordered pairs that would be here. So this tick mark is -3. This tick mark, the x value there would be a -2. This one's a 1. That point's on 0. We have another point here on +1. Nothing on 2. We have one on 3 and 4. So those are all the x values of those ordered pairs. Then you look at the y values for the domain, the range. So I see I have one range value here at 1, 2, 3, -3. The y values for these 2 points is -2. Nothing at 1, nothing at 0. I have something at 1, 2, and 4. So those are my y values. Now, if you can't really look off the picture and see that, you can list the ordered pairs for every dot and then list the domain and range. Remember, for graphs, we're trying to see if it passes that vertical line test. So if you draw a vertical line, scan the graph, if there's ever a spot where if you draw a vertical line and it passes through 2 points, like right here, passes through that point and this point, then it fails the vertical line test. So this is not a function. And you can simply say on the graphs, either it passes or it fails the vertical line test. And then lastly with the map. So this is nice and easy. It already kind of tells us domain and range by the above. So the domain values are -3, -2, -1, 0, and 1. Just the ones in the bubble. The range are 0, 2, 4, 6, 8. And is it a function? So you have to look at the domains. And if you see that one of those numbers is going to more than one range, or arrows out from the domain to 2 different y's, then it would not be a function, but this one is all good. You might think here where -1 and +1 are pointing both to the 6, but that's like 2 different people being in the same math class, so that's allowed. So this is a yes. It's a function. You could say no domain repeats. All right, so go back to this page. second. So go back and see if you can now easily answer yes or no, are these functions or not functions? And like I said, we'll check them the next day. So moving on here, the next concept in this is evaluating a function. So like if I input a number, what is the output? And we have three functions up here, f of x, g of x, and h of x. So we need to be careful about which one we go to. So f of -5 means I'm going to start with this f of x function. So I'm going to write that down so we know which one we started with. They want us to find f of -5. So that means for x, I'm replacing a -5. So if I, on the right side, replace x with -5, I just want to see what the output's going to be. So this stays f of -5. And this is -15 plus 2, which is a -13. So if I input a -5 into the f function, I get an output of a -13. So that's our answer, -13. The next one says g of -6. So I'm going to the g function here. And I want -6. So anytime you see an x, you're going to replace it with a -6 and do the math on the right side. So remember, you got to do the exponent first. So the -2 just kind of hangs out there. -6 squared is -6 times -6, which is positive 36. And if I take -2 times that, it should be -72. Which is correct. And lastly, h of 3. So now I want to go to the h function here at the end. And anywhere I see an x, I'm replacing it with a 3. And doing the math. So h of 3 equals -4, 3 squared, I have to do the exponent, which turns into a 9. Then you could do the multiplication in the next step. So this is -36 minus a 6 plus a 5. And then go left to right with this. -36 minus 6 is a -42. Add 5 to that. You get the output is a -37, I believe. So let's see if I'm right. Yes. All right, and the last part of your notes are these two questions, and I want you to try these on your own, critiquing Omar and Madison, seeing is either one of them correct, and explain. And then talk about the podcast question. How many podcasts will he have after 8 months? So you try those two. Also, after you're done watching this video in Delta Math, you'll have like a few quick questions to do in the program just to see if you're grasping the concepts in this video. All right, see you tomorrow.